So the quiz is on Canvas. It's on endo and exothermic. Raise your hands if you've already found it. That's like 4 people. All right. Well, let's show you where to find it. Anybody know what lab book we're in right now? Concentrate on this. So if you were at the top, these are organized by lab books. So we were done with everything chemistry. We're done with everything elemental tell. So we're in concentrate on this part 1 because there's 2 halves. And if you go right down here, it says endo and exo quiz. If you're ever gone, which I'm up to 15 quarantine kids right now, so you just never know. If you're ever gone, check the daily plan at the top. It's right here. And then it will tell you the title. So like if you were gone today, it says solubility of solids. You would go there and do that. All right, so endo and exo quiz. Take that quiz for me. It might be tricky. It doesn't load. Okay, so grab a different iPad if you have the same problem. If you were here or you hopefully attended online, we showed the video of the hot metal ball in water. And that was an exothermic process. And then the ice cube was the endo. What's that? It confuses everybody. Is that what you just said?
Yeah, I got 100, but
Well, if you got 100, then have. Oh, okay.
But it still like confuses me.
It's very confusing. That's why we're testing on it, and we're gonna talk about it the other day and again today.
Okay.
It's because it's backwards of what it seems like it should be.
I just gotta remember that.
It, yep. Think what you know, then go the opposite. Then you're in trouble. Yeah, you can put them away. There's small odds we'll get to another quiz, but I doubt we will. Let me get these damp. Oh, it goes right through. How is that possible? Yeah. Wow, this is a lot better than I thought it would be. And you got 100? It's pretty much what you got to do. You are not. You are not. Okay. So let's talk through this. If you struggled, it doesn't mean that you suck at everything, Megan. Okay. Uh-oh, where'd I put my black pen? Who thinks of this kind of crap? Get a black table, turn the lights off, and have black accessories. not smart. Okay. I hope that your weekend was nice and relaxing. I know mine wasn't. But I mean, that's all right. And now I can't find my writing utensils to make this thing worth using. Oh, who would have put it right there? Kids these days.
I'm on the lower end of that.
It's okay. Okay, so please, you'll see these exact same questions on the exam. So if you did well, that's awesome. Hopefully I don't make you dumber by reviewing the exam. Anyone know when it is?
Wednesday.
Wednesday. Good. You guys can read. That's a good start. It sounded passive aggressive. Oh,
You guys can read.
that's a whole new button. When they redid my computer, they redid every setting. So anyway, moving on. Here we go. Whew. A negative heat of solution causes the solution to become hot. Negative. That means that the solution lost energy. Where did that energy go? It went to my hand. If my hand is taking energy from the solution, all right, then I feel it as heat. Please try to tie negative heat of solution to something feeling hot. The solution loses heat to you. All right, then a endothermic means it's something that's cold. So of the two examples, which one was supposed to represent endothermic? The hot ball or the ice cube? Tell your partner. The ice cube. Endothermic. If you'll just think about endothermic being an ice cube, you can get through quite a few of these questions. All right, exothermic then, that would be something that gives off heat. And that would be the metal ball. The metal ball, it was bright orange, put it in water and it heated the water so it got hot. All right, then I'm going to predict this is in the 50s. Oh, well, close. A positive heat of solution. That means the solution takes in energy. If it takes it in, it's removing it from you, and you feel that as something that is cold. All right, these are similar. Takes in heat. That means heat is entering. Gives off heat. That means heat is exiting. Has a positive. We'll probably struggle here again. Positive heat of solution means it's endothermic. All right. A negative. That means it's exothermic. And then it's like the hot ball. You should have got 100 on this. I said it out loud while you were taking the quiz, but maybe some fasties were already done. All right. The hot ball is exo. The ice cube is endo. All right. We will review this again, but if I come all the way to this slide, right here, please look through this. And if you struggled, you may want to write this down on your own piece of paper, on your lab book, somewhere in white. I'll leave this up for a few minutes. It's just a general statement of the properties that are endo and exothermic. You do not have to write these down, but if you struggled at all, please do. Like put ice cube and then write all that stuff, and then put hot metal ball and write all that stuff. I'll leave that up there for about 4 minutes. I'll pause this recording. You two soccer players, if I don't unpause it, you. All right. So this is one of the competencies. I should say these are endo and exothermic. They are something that's a little bit tricky for this unit, and then another one that comes out in like a month or two. Unless you're in third try, then it's forever ago, or not ago, forever in the future, and you'll forget it. Whew, here we go. So today we have page 8. If you would turn there, that's. Solubility of solids. This is also stuff that's directly on the test on Wednesday. Is it too dark? Do you need more light? Okay, I heard a lot of no's. All right, just a quick review, by the way. This thing, which you probably can't read very well, but where would this have come from? Any guesses? Canvas on the daily plan. The daily plan. Of the 15 kids quarantined, I'm getting like 2 that are actively doing anything, and I'm getting 13 that come back 2 weeks behind. Like, I'm giving daily stuff. I'm posting the video every single day. The expectation is that you come back ready to roll. All right. Now, I know that expectation's not being met, but that would certainly be the hope. All right. Solubility of solids. So here is the first part. Fill that in and then I'll talk. The solute is like the salt. Solvent is the water. Okay. Oh, never mind. You're still looking down. They're whack? Uh-oh. Oh, man. I'm sorry. I did not inspect them. We'll just add it to my list of technological failures in the last 7 days. This is what they're supposed to look like up here. Let's see. Yeah, it's missing that whole solubility, right? I bet when I dropped that QR code in there, it moved things and I didn't even notice. So I apologize. All right, so here we go. When an excess amount of solute is added to a given volume of solvent at a given temperature, the dissolving process will take place until no more solute can dissolve in the solvent. Okay, so let's, oh, that's upside down. That would be a trip. Let's try and figure this out. If I put this in more like normal terms to you, oh boy, just pretend that looks good. Okay, so here we go. This is milk. And here are your Cheerios. Who's ever had milk and Cheerios? Raise your hand. Okay, so most of us are okay with this. Just plain Cheerios and milk is disgusting. So we hide that flavor with what? Sugar. All right, we add sugar. All right, if you haven't ever done that, I'm sorry. When I was in high school, I had a kid, he was a friend of mine. His parents wouldn't let him have sugar or milk, so he ate Cheerios with water. Yeah. Poor kid. His name was James David. And there was another kid in my school named David James. And they got their names backwards all the time. Okay. So let's define this top paragraph with this. When an excess amount of sugar is added to a given volume of milk at a given temperature, the sugar dissolves until no more sugar can dissolve. All right. And then when it won't dissolve anymore, we're used to that. It goes to the bottom and you scoop up a little chunk of sugar each time you take a bite. You're like, oh, Cheerios are pretty good. No, they're not. Sugar is. Right? Okay. So what we're talking about is the ability of something to dissolve. Its ability to dissolve is very dependent on the temperature. I don't know what that sound is, but it sounds interesting. All right. So how many of you have gotten hot chocolate and just had a drink and it was good? Okay. How many of you have left it for a half hour and went to take a drink and it was disgusting? Okay. So this is what happened. Hot chocolate is best when it is what?
Hot.
Hot. All the chocolate and all the sugar and all the other nice flavorings are nice and dissolved throughout the solution. All right. But you leave it for a half hour, all that stuff now sinks to the bottom. Because probably all of us have had a hot chocolate cup where it's just straight black at the bottom, right? And that's because as it cooled, it became less able to hold stuff. I'm intrigued. I gotta just look. What is going on out here? Oh, sounds like they were something glass or something. It's so exciting. Okay. So once again, as it gets cool, it won't hold as much. So your sugar, your chocolate, all the delicious stuff goes to the bottom, and you're left with mostly off-colored water. Right? So the dissolving process is dependent on temperature. All right, we have this word right here, solubility. That's a matching term, I'm sure. Tomorrow we'll do a Quizlet or a Kahoot, we'll see. Solubility, that's the amount of substance that dissolves in a given quantity of solvent at a given temperature to produce a saturated solution. Okay, so it's the amount of sugar the milk can hold at a certain temperature. That's all that we mean by solubility. We can change it based on its temperature. All right, I hope the next slide, whoops, that's different also. Hopefully the next slide is not as whack. Yeah, I think we're all right on that one. All right. You got 30 more seconds. Okay. This is the first time, I believe, in this class we've used the term equilibrium. We will use it throughout the year. So please know what we mean by an equilibrium. Equilibrium in science means there's a change, but not really. And I'll explain that with an easy example. All right, I'm walking down the hall and I find a $20 bill. And I'm like, sweet. And I go to put it in my wallet and I realized I lost a $20 bill. So I just found 20, but I'd already lost 20. So what was the change? None, really. Okay, so I probably have a different $20 bill, but overall I still just have $20. You all right with that? So equilibrium was when there's sort of a change, but the overall change in the system is zero. All right, so we'll just keep talking about it. So there's no net change when we reach a saturated point. The particles of the solute move from the solid and the dissolved state back to the solid state. This solid to dissolve process happens at the same rate, producing a dynamic equilibrium. Dynamic means it's constantly changing, but the net change is zero. All right, so what we're saying, you have your milk, you have your Cheerios or whatever you choose to put in here. Then you're going to add your sugar. What this is saying, if we've reached a point where it's saturated and there's sugar at the bottom, I can still add sugar. If I put sugar in, some of it will dissolve. But if some of it dissolved, then some of it started to reform at the bottom. In fact, the exact same amount. So when we have something that is fully saturated, meaning it's holding as much as it can, if more dissolves, then more came out at the bottom. That's all it's saying. So another example here. Due to COVID-19, you can have 50 people at this party. All right, and you invited 49 of your best friends and 48 of your best friends and then you invited me, Tom Davidson. And then, I forget these are different. Then someone knocks at the door. Who's someone that is super cool in pop culture right now? Beyonce. I don't know how to spell her name. That was hilarious in your debate class, by the way.
Oh, thank you.
Beyonce. We'll just go like that and call it good. Sound all right? She knocks on the door and you open up that door and it's Megan, who I believe is a Beyonce fan. She basically is Beyonce. I learned that in debate. So Megan opens the door. Is she going to tell Beyonce, I've already got 50 people. We can't let you in. No. She's going to say, Davidson, you weren't really invited, so you got to go. So Tom leaves. Beyonce comes in. Now, Beyonce comes in. All right, so she comes in, I go. Tell your partner, how many people are in the party now? 50. Did the total number change? No. Did the party get more lit?
Yeah.
Prompts, right? All I do at dance parties is yell at you to put your masks on and to quit moshing. And she's just busting out the single lady dance. So definitely the vibe changed, but the overall change in people is the same. Okay, there really wasn't a change in the numbers. It's the same thing. Sugar can dissolve, but if it dissolves, some of it had to come out. And that is an equilibrium or a dynamic equilibrium. All right, now, this is the part that's mostly on the test. So fill those notes in and then we'll hopefully get this to make sense. Most people do really well on this part, as long as I explain it. All right, take about 1 more minute. And then we'll talk. Oh, there's a lot here. Maybe need more time. I'll just go over here and get a drink. How's your Snapchat? Good. How's the weather? Uh-oh, it doesn't exist. Oh no. I'm gonna guess it is sunny with a high of 68. 70? That's close. With a high chance of flies in your house. What? 68? I didn't even cheat. I hate being a genius. It's so hard to be me. Just walking around knowing everything and knowing people around me don't. That is a struggle. One of my children was watching a trivia contest between YouTubers over the weekend, and they are really dumb human beings. Can I just say that? Does anyone know what I'm talking about? They're dumb. Yeah, Mr. Beast's trivia / common sense challenge. The winning question for $300,000. The winning question was, how many slices are on a typical pizza? 8. You could have won 300 grand right there.
I work at a pizza place and people call and ask that.
Yeah. So how many for a large? Okay. How many for a small? Oh, well, I want more. So anyway, sorry. That was recorded. I just roasted Mr. Beast, who I'd never heard of until yesterday, but whatever. Okay. Saturation. These are 3 matching terms. So make sure you're okay with those. This is on the test in 2 ways. And tomorrow we're going to review this 100% again and knock this out. Question or stretch? Yeah, go ahead. Okay, so please know, you've heard of the word saturated before. Probably unsaturated, but probably not supersaturated. So to just knock the definitions out real fast, saturated is holding the maximum amount of solute for a given amount of solvent at a certain temperature. So first off, let's put that in English. Saturated is when your milk is holding exactly the amount of sugar it should at that temperature. Unsaturated holds less solute than a saturated solution. So unsaturated would mean I could add more if I wanted to. You okay with that? Like today, I drove my truck to work, and my truck has 6 seat belts. So if it was saturated, I would have 6 people in there. That's how the state defines it. Occupancy is equal to seat belts. I know you're teenagers, but whatever. Here we go. So saturated would mean it was full. I had exactly 6 people in my truck. Unsaturated, I drove to work today, completely unsaturated in my truck because it was only holding 1. I could have added 5 more people, right? Okay, and then super saturated, that would be I'm a super teenager and I have a truck, so let's put 22 people in it and go to a party. It's holding more than it should. Super means above, all right? So another way of saying it is above saturated, it holds more. Now, to make a supersaturated solution is tricky. You have to heat the solution, add a ton more than it holds at the original temperature, but you add it while it's hot so it can hold more. but then you let it cool undisturbed, and it will stay a liquid until like you add another crystal or you hit it with something, and then it just turns into a solid. Okay, so supersaturated, it's the matching term that's forever long. Can you just remember that one? It holds more because you have to heat it and then let it cool and disturb. Okay, now, those are the definitions. But now on a graph, we need to know how to answer these questions. So on the test, it will give you the identity of something. So we've been talking about sugar this whole example. So you look at this graph, and where I drew this green line, this is representing how much sugar 100 milliliters of water can hold at certain temperature. Okay, one more time. It's how much sugar 100 milliliters of water can hold at specific temperatures. Okay, now I drew these 3 arrows, and if you put them in your notes, it's fine. If you didn't, it's fine. Saturated on a graph, saturated would be a point that is exactly on the line. So on the test, if it said a sugar solution at 20 degrees is holding 200 grams of sugar, is it saturated, supersaturated, or unsaturated? I lost track of what I was saying. But since it's on the line, the exact line, we would say, oh, it's saturated. So on the exam, if the data point I give you ends up right on the line I'm talking about, we say it's saturated. Okay, I'm going to erase all this. And now let's talk about unsaturated. We're still talking about this green line. Oh my. Oh, way harder than you think. I'm going to give myself a standing ovation for that. Okay, this green line, unsaturated. If the data point I give you is underneath this line, anywhere in here, we'd say it's unsaturated. So this one would say, if a sugar solution at 40 degrees has 180 grams of sugar in it, is the solution saturated, unsaturated, or supersaturated? Since it's under the line, it is unsaturated. If it's under the line, it is unsaturated. Okay. Super. What does super, the prefix, mean? I said it a minute ago. It means above. So for supersaturated, if I give you a data point that is above the line I'm asking you to reference, then we say it is supersaturated. So if the test question said a sugar solution at 40 degrees holds 300 grams, is it saturated, unsaturated, or supersaturated? Oh, what are you doing? Since it is above the line, we would say it is supersaturated. Okay, so that's how you'll see these on the exam. You need to know the definitions. You need to know how to see them on a graph. And then usually, I don't know, most kids do fine on these as long as I teach it today and we review it tomorrow. Questions on that before I move on? Okay. Oh yeah, he's putting E's. That's kind of fun. E. All right. Now, these questions in there, they're on the homework. Let's turn to page 17. Because nothing's better than homework at school. Because then it's not homework, it's schoolwork. All right, I don't know if these are the right numbers still, but are they 12, 13, 14, and 15? So maybe it's page 18. Sorry. Okay. So this is graph reading 101. Let's work through these together. Looking at this graph right here, number 12, what substance's solubility is least affected by changes in temperature? If you'll look, this graph is showing you solubility versus temperature. So on a graph, the one that's least affected would be the what line? Tell your partner or tell them you have no idea what I'm talking about. That was probably gross on the video, I apologize. Okay, I heard Thompson. Anyone else have a guess? Chad? Straightest, that's sort of true. What you mean is the flattest, because you even went like that. It's the flattest line. So the flattest line would be salt, NaCl. The inverse of that question, what's the one most affected by it? It'd be the steepest, right? So I would say either one of these two would be a fine answer, probably barium hydroxide. Okay, now 13. Reading a graph, by the way, is half of the ACT science test. It's not your ability to know chemistry, it's your ability to look and interpret graphs. So 13, what substance shows a decrease in solubility with increasing temperature? There are a few of them. Tell your partner, at least one of them. What one shows a decrease? All right, no one has any idea what this is called. I don't even know. It's ytterbium sulfate. It's probably ytterbium 6 sulfate, but whatever. That stuff, right? So on a graph, if we're looking for something that decreases, we're looking for the downward slope, essentially. Okay? So it's either one of those two answers. You can write one of them, or you can write both of them. Those are the two that decrease over time. All right, number 3. Oh, sorry, 14 technically. What substances, I already answered this, didn't I? The most affected is the one that's the steepest. And I'd say it's probably barium hydroxide. If you already wrote KNO3, don't erase it, it's fine. All right, 15. Now it's just a straight graph question. It's not asking for you to interpret a relationship. It's just straight graph. What's the concentration of KCl at 50? So you find 50 and you go up until you see the line for KCl. It's right there. And we'll have a bunch of different answers, but around 42, 43, you okay with that? Right. Number 16. At what temperature? So we're looking for a number down here. At what temperature does the solubility of KNO3 begin to exceed KCl? So KNO3 is, oh, this is going to be tough. It's this curvy one right here. And that's terrible. It's right here and right here, right? So if you just say, I don't know, 22, 23, 24, 25, I'm fine with any of those. So you just find where they cross right here. This is oh. All right, 17 is the hardest question on the whole part. It is a tricky question because I'm not a nice person. So first off, we're looking at NaNO3. So this line right here. How many grams of it will dissolve in 400 grams at 10 degrees Celsius? This is a very typical type of HCT question that's just there to screw your life over. Because you're like, hey, I know what to do. I go to 10 and the answer is right here. And you think it's 80, but this is per 100 and this asks per 400. So it's 320 grams. I'll talk more about that. We're almost out of time. All right, 18. Not too hard. As the temperature increases from 70 to 20, what happens to the amount of KNO3? So as I go this way, what happens to KNO3? It goes up. The hotter, the more it holds. Oh, it does? Sorry. You're right. It says decrease. I should have read. That's my fault. So it's asking this way. Seconds. Here we go. If 30 grams, so this is important, of KNO3 at 60. So I'm going to find 60 and 30, and it's right here. What's that? All right, good. That is under the line of here. That's a terrible arrow. So we would say it is unsaturated. Okay, we will do more of these tomorrow to review. We just have a tiny bit of notes and then all review tomorrow. You guys are great. Have a good day.